Alrighty. Case 4, objects on a surface with friction. We got mass 2 with an applied force of 10 newtons, just like the last one. Connected to mass 1 through tension, and mass 1 is just there. Mass 1 is 1 kilogram, mass 2 is 3 kilograms again. The applied force is 10 newtons again. This one's just different because it has an added friction. And the coefficient of friction is 0.1. We're trying to find acceleration. Free body diagrams for mass 1. Force of gravity pulling down, force, the normal force acting up. We got the force of tension pulling right, and now we have the force of friction pulling left. Mass 2, we've got gravity pulling down, normal force pulling up, the applied force pulling to the right, and we got force of friction and force of tension pulling to the left for mass 2. Both the accelerations are positive, and we're going to find, for step 2, we gotta analyze what's common, what's equal. What's common, what's equal. Acceleration 1 is equal to acceleration 2. So we'll call that acceleration. Same thing with the tension, because it's one rope. Call that force of tension. Gotta write F equals ma. It's positive for mass 1. For mass 2, also positive. Gotta find all the forces acting on any given object. So for mass 1, that's going to be the force of tension minus force of friction. For mass 2, that's going to be the applied force minus the force of tension, also minus the force of friction. I'm going to equate these equations. So, step 5. Force of tension minus force of friction is equal to M1A. The applied force minus force of tension minus force of friction is equal to M2A. Step 6. We got to expand the equations and simplify the labels. This force of friction can be written as coefficient of friction times the normal force. And normal force can be written as force of gravity. And this can be written as M1 times gravity. And gonna be the same thing over here for the friction. But let's rewrite this. Force of tension minus coefficient of friction times mass 1 times G is equal to M1A. This, the applied force minus force of tension, can be written as this can be written as force, the normal force, and then that to the force of gravity, and then this to mass 2 times G. And so we're gonna subtract coefficient of friction times m2g equals m2a. These two are two unknowns, and these two are two unknowns, the tension, and so we're going to substitute and combine these two equations. Force of tension is equal to M1A plus coefficient of friction M1G. So we're going to substitute into one equation the applied force minus M1A plus coefficient of friction M1G minus coefficient of friction M2G is equal to M2A. This can be written as, so we're going to apply this to that and that. So the applied force minus M1A minus M1G minus coefficient of friction M2G equals M2A. Now we're going to solve for A by simplify both sides. Put anything with an A on to one side, so we're going to move this over here. Plus M1A. And then we can isolate, so this is acceleration times M1 plus M2 divide M1 plus M2 divide this side M1 plus M2, and so rewrite, solve for A. Acceleration is equal to applied force minus coefficient of friction times M1G minus coefficient of friction M2G all over M1 plus M2. And so that's going to be our solve for A, but now we can plug in things that we know, because we know what M1 is, we know what M2 is, we know what the coefficient of friction is, we know what gravity is, we know what the applied force is. We know all these, gotta get A. So acceleration is equal to 10 newtons minus 0.1 times 1 times 9.8 minus 0.1 times 1 times 9.8 all over M1 plus M2, which is 4. And then if you equate that all, that will leave you with acceleration is equal to 1.52 meters per second, and that is our answer.